Hello and welcome to my new video. In this one, Charlotte lends me her AI voice again to narrate my adventures with the IP adapter version 2, the JuggernautXL-Lightning Model, and my idea this time to pack the Gestalt Laws of perception and other principles of processing visual stimuli into the prompts. The video should have been published a long time ago, but then the upgrade to the IP adapters came out. This second version not only replaces its predecessor, but also requires all previously created workflows to be adjusted. You can already see here that the JuggernautXL-Lightning Model is ideal for generating great images quickly and efficiently. And above all, to make something out of my experimental prompt inputs. The weaknesses of the model that only 4 to 6 steps are allowed for good results, and the CFG value must be between 1 and 2, as well as the fact that it only runs with the DPMP SDE sampler and the scheduler set to normal, and that the only resolution that works well is 1216 to 832, are overshadowed by the obvious strengths. Juggernaut is a fitting name. These laws or principles of visual perception are law of closure, law of proximity, law of similarity, law of symmetry and order, figure-ground relationship. Methods of image design can be derived from these principles. Perception and depiction work together to create interesting effects, such as color illusions, depth illusions, motion illusions, geometric illusions, and the model can reproduce some of these effects with quite convincing results. Now that we have some suitable images, we can proceed with the IP adapter embeds version 2 setup. This requires the basic setup for the SDXL models, 2 load image nodes, the new IP adapter advanced node, the IP adapter model loader, and the load clip vision node. And of course the prepare image for clip vision nodes, which convert every loaded image into a square shape and offer additional functions: interpolation, selection of the relevant part of the image, and the option to resharpen the image. We then connect the 2 images to the IP adapter advanced node via the batch image node. For the embeddings, we still need the IP adapter encoder, one of the new nodes. We then only need to connect this to the IP adapter save embeds node, and we are ready to go. In the IP adapter advanced node, you can already see the first new options. However, my tests have shown that in weight type, linear, and for combine embeds, average are best suited for creating the embeds, even if there were a few interesting surprises with the other options. You can watch the different results in the uncut version of this video if you like. But let's get back to the IP adapters. To test the changes to the IP adapters, I created a new workflow that runs as many of the new functions as possible through the K-sampler. Not all of them made it into the workflow, simply because my NVIDIA RTX 3060 has reached its limits despite the considerable 12 GB of VRAM. But as you can see in the course of the video, the new adapters help me amazingly well to get a lot closer to the goal of exerting as much control as possible over the image to be generated. Part 2. I call it Controlled Mask Madness. Here, of course, we also need the basic setup again. And as the JuggernautXL-Lightning Model is to be used here again, we need to set the steps in the K-sampler to 4, the CFG value to 1, the scheduler to normal, and the sampler to DPMP SDE. In the empty latent image node, the resolution must be set to 1216 to 832, as previously mentioned. To give us more control over the image generation, we now create a mask for the left and right side of the image. This requires a load image node, 2 solid mask nodes, the feather mask node, the mask composite node, and an IP adapter advanced node. As you can see in the video, we need to tie these together and add a mask preview node for control purposes. Then we can select the whole thing with Ctrl plus left mouse button, press Ctrl plus C, and insert it to the right with Shift plus Ctrl plus Alt plus V almost completely connected. One of the new things is the IP adapter noise node, which allows us to add more image noise to the IP adapters, according to the motto, "The more image noise, the better." This is good because, roughly speaking, it gives the adapters greater scope for processing the input. And the great thing about the noise node is that it also gives us more control over the image generation. Simply because we can set the type, the strength, and even add a blur. And we can also add an image via an image loader. All of this has quite an influence on the final image. We can also connect the image noise to all IP adapter nodes used in the workflow via the IP adapter encoder node or the noise node. All we have to do is connect the image output of the noise node to the image negative input of the adapter, or the pulse embed output from the encoder to the neg embed input of the IP adapter embeds node. This means that the image noise is omnipresent. If we want to use multiple embeds, we can connect the embeds to the adapter via the next new node, the IP adapter combine embeds node. And there are also several new functions for processing the embeds. More on this later. The workflow has not yet been fully set up. For the next task, we need an IP adapter encoder node, an image loader, and an IP adapter embeds node. Of course, we send the loaded image through the prep image for clip vision. Once we have tied everything together correctly, we move on to the last point of the setup. For this, we need the known nodes for a control net. In this case, for an open pose SDXL model. Now connect the checkpoint with all the adapters in the correct order, and the setup is finally complete. The output images and the settings for the various nodes are still missing. The IP Adapter Plus models are very effective, so it is better to start with low values for weight. This, let's call it a module, is used in the workflow exclusively to transfer the style of the source image. That is why the weight value is so high. To influence the left side of the image, we now need to set the mask. To do this, the operation Add must be selected in the Mask Composite node. In Feather Mask, we should set Right to 350 relative to our preset image resolution. The Solid Mask, which is connected to Destination, specifies the overall resolution for the IP adapter. So in our case, we have to set it to 1216 to 832. However, as we only need the resolution from it, we must not forget to set its value to 0. Otherwise, the mask will only remain a black area. For the mask that is important for us, we should set its width to a value relative to the overall resolution in order to influence the left side of the image. The 608 pixels are exactly half. The height can of course remain at 832 pixels. The settings for the mask on the right side differ in that the black area on the x-axis must be shifted by 608 pixels, and the value in the Feather Mask node for left should be set to 350, at least for the time being. As far as the various settings in the new IP adapter are concerned, I have tried them all in various test workflows. In addition to this little insight here, I'll put the entire recorded test series in the uncut version. It's definitely pretty cool what you can do with the second generation IP adapters. But a word about the JuggernautXL-Lightning Model, as it has its limitations due to the strict resolution specification. I certainly tried to incorporate an upscaling method into the workflow, but the methods based on models exceeded the performance limits of my computer. The upscale image node worked without any problems while maintaining the image ratio. Have fun trying out the workflow. If you found the video interesting and/or helpful, I would appreciate a like and subscribe. Otherwise, have a great day.